Hi, I'm back again, and in this module I'm going to continue on with the gradebook that I was creating. And I stopped when I did because what I want to get into now is the use of formulas and functions, which is, one of the key features in a spreadsheet program. And in order to demonstrate this, I want to, do a little bit of make-believe here. We'll pretend that at some point in the semester, near the end of the semester, maybe after we've recorded all the grades except the test. So let me go ahead and very quickly put in quiz 3 scores, and I'll just give everybody a 100 real fast by dragging on the fill handle here. Okay, now we're at the end of the semester. And we're going to pretend that, let's say Larry comes in to my office and says, I'm a little concerned about my grades here. I'm a pretty good student, but haven't really done that well on the test, and I had one quiz grade that wasn't so good. Could you give me some idea of, what I can expect as a grade in this class? And I would tell Larry, I'd say, well, let's do a little what-if analysis here. Let's go ahead and put in a computational expression like the one that I'm going to use when I really calculate your grade at the end of the semester. And so I'm going to go to cell L5 where Larry's grade will be calculated, and I'm going to enter in a formula. Okay, so now there's two ways that I can perform calculations. I can sometimes use built-in expressions known as functions to perform calculations, and that's really the most convenient way to do it and the preferred way to do it. So if it's a routine type calculation like finding an average, calculating variance or something like that, then there are built-in expressions called functions that are easy to use, that are very reliable, that are extremely well documented, and that would be my first choice anytime I need to do a calculation. But in this case, because of the way I calculate a weighted average, there isn't a built-in function available, so I have to craft the expression myself. And in this case, I'm going to use what's called a formula. So in creating this formula, I go to the cell where I want the computation performed, and with all formulas and functions, I have to begin with an equal sign, so that's just a syntax requirement, and I'm going to type in an algebraic expression then that'll perform the computation. And what I want to do is find the average of the test and weight the average of the test at 60%, and then find the average of the quiz and projects and weight the average of the quiz and projects at 40%. So the 60% grades, 40% projects and quizzes will make 100% of the total grade. So how do I do that? Well, in Excel, you basically apply the same rules that to a formula that you have learned in algebra. So there's an order of operations, multiplication and division get done ahead of addition and subtraction and so forth. And parentheses are used to override that natural order of operations. So in this case, finding a weighted average is really a three-step process. I have to add up the cells that are used in the calculation. I have to divide by the number of cells, and then I have to multiply through by my weighting factor. So I'm going to need to force these operations to occur in a very strict order, and there are three operations that have to be performed in a very specific order. So I'm going to start out with 3 opening parentheses, and in Excel, a couple other rules that I should tell you. These are rules specific to Excel. If you're going to use nested parentheses within parentheses, then you always have to use rounded parentheses. You can't, mix it up with brackets and braces and things like that that you might do in algebra. So you have to use the rounded parentheses. Secondly, there is no implied multiplication operator. You have to explicitly specify multiplication with an asterisk. So the actual arithmetic operators that are used are plus for addition, minus for subtraction, a slash for division, and an asterisk for multiplication. And so in this case, I want to add the contents of cells C5 and D5. C5 plus D5. I should also tell you that in Excel, one of the rules that apply in creating both formulas and functions is that you cannot have embedded spaces. So, all your life you've been told, hey, put spaces between words or between symbols or whatever it might be to make it more readable. Here, can't do that. If you put in a space anywhere, the formula won't be recognized correctly. You get an error. So within this interior set of parentheses, I'm going to add the two test scores, and then I'm going to divide by 2 within the middle set of parentheses, and then finally I'm going to multiply through by my weighting factor, which will be 0.6, and that will weight the average of the test at 60%. And to that, I want to do something similar with the quizzes and projects. So again, 3 opening parentheses, and I want to add up cells F5, G5, H5, I5, J5, and K5. Now there's every opportunity to make mistakes here, so I'm going to look at this carefully. F5, G5, H5, I5, J5, K5, 1, 2, 3, 4, 5, 6. Okay, so I think I've got it right. So I'm going to add up those 6 cell values, which represent the scores on projects and quizzes, and I'm going to divide by 6 the number of items in the list, and I'm going to multiply through by my weighting factor of 0.4, and that'll weight the average of the quiz and projects at 40%. Excuse me, 40%. And when I perform that calculation, it comes back with an 81.67, okay, which is maybe a little higher than I had anticipated, because I include cell, I did not include cell E. That's where I went wrong, okay. So what I could tell Larry is this: right now, with what grades you have, you're sitting on a low B. But instead of just including 2 tests, let's put in 3. So I'm going to add now E5, and I'll need to divide by 3 when there's 3 items in the list. Okay, so C5, D5, E5. I'm going to come out here to the end of the expression and click the mouse, get the cursor positioned at the end, and then hit the enter key. And Larry says, oh geez, how did my grade sink from an 81 to a 66? And I would tell him, well, it's because in revising this calculation, I reference a cell that doesn't have anything stored in it. And anytime I reference an empty cell in a spreadsheet formula, the spreadsheet formula will treat an empty cell as though it contains a value of 0. So if I were to put a 0 in here, it will not affect the calculation. Okay, get the same calculated result. And so what Larry's looking at right now is worst case scenario. If he fails to show up for the final test, then he'll get a D in the class, and it's not likely that he's going to do that. So he may say, well, what if I just study like I've studied before, and we'll take some sort of middle score. Maybe I'll study a little bit harder, and I'll get a 70. So that would be in the, approximately in the range where he's been scoring up to this point. So if we put in a 70, the spreadsheet program will recompute automatically, and a 70 will get him a B. Okay, so Larry says, okay, understand worst case scenario, I get a D. Likely case scenario, I get a B. What would be best case scenario? And I say, well, okay, best case scenario is you get a 100. Absolute best case scenario, and that's going to only raise his grade 6 points, which still is shy of an A. And what I would tell him is, manage your time if you've got other classes, because you want to perform well on this test, but at the same time, there's a an upper limit here. You can't get any higher than a B. So what I'm going to do then is I'm going to copy this formula down, because it really isn't much fun to type this in. And I want the same basic formula applied to row 6 and then to row 7. Currently, if you look at the cell values, they all show cells on row 5. And I can also copy it the opposite direction, again by dragging on the fill handle. And I want it to adapt itself to the new rows that I copy into. So when I copy a formula or a function, the spreadsheet program copies in a relative way. Okay, so by default, it will copy that formula and function in a relative way. And what that means is that as I copy down a column, the spreadsheet program will automatically adjust the row coordinates. And if I copy across the row, the spreadsheet program will automatically adjust the column coordinates. So in a spreadsheet program, formulas and functions by default copy in a relative way. All right, so I'm going to go ahead and put in some final scores here. We're going to pretend that the semester has now officially ended when I put these scores in. And let's give this guy a 77. Okay, so everybody did reasonably well. Now, let's say that as I look things over, I realize that, whoa, Shemp did not get a 77 on that. He got a 7. I'm going to hit the enter key, and that takes his grade down to a 65. And furthermore, I look back over my records and realize, oh, I've made some mistakes. This guy, I guess that was Larry there that, let's see, no, Shemp got the 7, and let's pretend that, I'm looking back over my grades and I realize, hey, not only did he get a 7 here, but he got a 4 here instead. Okay, so he didn't get he ends up with a calculated grade of 57, which is going to be failing. I want to intentionally force some people to fail. Okay, so he's going to get a letter grade of an F, and he'll definitely fail. And I'm going to give somebody else a D here, so I'm going to have to adjust someone else's grades downwardly, and I'll do it to this guy. Let's say he gets a 1 instead of a 77 there. And that puts him at a 69.2 in the calculation. So I'm going to colorize these just for the moment here. I'll mark them with yellow. Okay. And now what we're going to do is take a look at a couple of functions. Okay. So you saw how formulas were constructed, and a quick review of that begins with an equal sign. When parentheses are used, they excuse me, they have to be rounded parentheses. My arithmetic operators are plus for addition, minus for subtraction, slash for division, asterisk for multiplication. I have to follow the standard rules of algebra in constructing the expression. So these are all things that pertain to formulas. Now, again, formulas work, but if functions are available, I definitely want to use functions. And there are some things that functions can do, like manipulating text and in performing logical operations that I simply cannot do with a formula. So let's take a look at functions, and the first function I want to put in is a function that is going to, well, let's put in one. Let's find out what the average is for the class. Let's do an easy function here first. So we find out what the weighted average is for each of these individual sets of scores. Let's see what the overall average is, not weighted average, but the average of the weighted averages are. So in column, or in row 9, I'm going to put in a label that says average, and I'll come over here to column L, and I'm going to insert the average function equal A. Now as soon as I strike the A, the IntelliSense kicks in, which is this interactive help system, and suggest several functions. When I type V, it's going to advance into the IntelliSense list, and there's the average function, the keyword for the average function. So if I double click on it, it'll automatically write that for me. It saves me a little bit of typing, saves me the the potential of entering in the keyword spelled incorrectly. And now it wants to know what cells do you want to manipulate in this function. And the cells that I want to manipulate are cells L2, L3, L4, L5, L6, L7, which happen to be contiguous cells. Okay, so no break, no interruption among those. All these adjacent cells, I want to, I want them to be in the range, or I want those to be the cells that I manipulate. So when I have a grouping of cells like that is contiguous, I can specify that collection of cells with what's called a cell range, where I give the address of the first cell and the address of the last cell. So in this case, I want to make my range L2 colon L7. And I can either type that in, or I can come up here with the mouse and highlight the range, in which case the spreadsheet program will automatically type it in for me. And then I would close off the parenthesis, and what you see there is a function that's built into the spreadsheet program, and I don't have to describe algebraically how I want the calculation done. All I have to do is invoke the function by its name, and then I have to tell it what cells I want it to manipulate, and the details of the calculation are built in, and I don't have to worry about it. And so what I've done is, within parentheses, I've provided what's called an argument. Okay, and I have used a single argument, and the argument that I have used is a range of cells. So what is an argument? An argument is a component part of a function, and it's a component that's specified between parentheses, and how many arguments you can have depends upon the function being used. In the case of the average function, I can have any number of arguments. So I could list individual cell addresses and separate them with commas, and each cell address would represent a different argument. Or I could have, a second range of cells, put a comma, and then to specify another range of cells. So you'll see examples of this, but for now, just try to pick up on some of this vocabulary. Functions are built-in expressions, and they're invoked by some known keyword, and we tell it what data to use by specifying arguments. And when I hit the enter key, calculates the average is 79. Now I might want to do that. I might want to know that, because that might influence later on what letter grade I ultimately give these students. Okay, my grading scale says that 90 to 100 is an A, 80 to 89 is a B, and so when I look at these calculated averages, I mean, they're pretty much dead on, and if I see that there's a score of 79.8, I probably won't adjust anything. You know, that tells me that throughout the semester, you know, I've been reasonable in the way I have scored things, and you know, this is about what I would expect from a class, especially a graduate class. Is that, you know, the average grade is somewhere around a B, okay, or in the B range. So I want to now decide. I'm going to skip the grade part for a minute. I'm going to skip, you know, entering in or having the spreadsheet program assign grades, and rather move over here and have it assign either the word pass or fail. Okay. Now I could do this manually, but I will show you another function here, and a function that, you know, once you see how it works, you'll undoubtedly use a lot in the future. And this function is called the if function. Okay, so how do I know about all these functions? Well, I've used a spreadsheet program for many years. Okay, that would be the short answer. I've also, you know, investigated the help files, and if you go to the home page, you'll see right here beside where it says auto sum, down arrow, and if I click on that down arrow, it will suggest some functions that I might want to apply, and if I want to find information on these functions, I can either select them from the list here, or I can go to the more functions option, and it comes up immediately with the if function. Okay, these are functions that I have recently used, so the spreadsheet program is you know, recording in the background what I have used most recently, and I've used an if function recently, so it shows up in the list. Now that list, this most recently used function list, may be different. You know, it probably will be different on the computer that you work from. So I have some other ways of filtering for functions. If I want to see every single function listed in alphabetical order, then I can say all. And there's a fairly extensive list of functions. I don't know how many there are, but there's a lot. When I scroll real rapidly, it doesn't seem like there are, but you know, you can investigate that on your own, and you'll see that there are many functions available. If I know the general category, like the if function I know is a logical function, if I click there, then it's going to shorten that list considerably, and I find the if function. If I highlight it, then I see in bold down here the general form that all if functions have, regardless of how they're applied in a spreadsheet. And I'll just point this out to you that every if function will begin with the keyword if, and then it will have 3 arguments. The first argument is a logical test, or you may hear me call that a Boolean expression. A Boolean expression is a true-false expression, and if that Boolean expression evaluates true, then the if function will perform whatever is specified by the second argument. If the Boolean expression evaluates false, the if function will perform whatever is required of the third argument. So we have the, think of it this way, the keyword if, and then an argument list that consists of argument number 1 being the Boolean or true-false expression that we construct. Argument 2 is whatever we want to have happen if the Boolean expression evaluates true. Argument 3 is whatever we want to have happen if the Boolean expression evaluates false. So I'm going to cancel this out and just type this in, and I'm going to put in equal, and again, a syntax requirement, every formula and function has to begin with an equal sign, equal if. It is not case sensitive, so you can type it in uppercase, lowercase, or mixed case. And then I have to create a true-false expression, And I want to create a true-false expression based upon this calculated weighted average. And what I'm going to provide as an expression is if the value in L2 in this case is greater than or equal to 70, then I'll have it say pass. Okay, so if L2 greater than equal 70, that's my Boolean expression. So when I look at this cell that's being referenced, L2, that expression really reads 97.4 greater than equal 70. That's either a true statement or a false statement. And if it's a true statement, then I will put in a comma, put in a second argument, and I'm going to use what's called a string literal. So I put in the string literal value pass. So anything that is framed in double quotes is known as a string literal. And then my third argument is, what am I supposed to do if the Boolean expression evaluates false? I'll have it display the string literal fail. And close off the double quotes, close off the argument list with a right parenthesis, hit the enter key, and that seems to make sense. Now, as I mentioned before, I don't really want to type that in over and over again. It's error prone and time consuming. So what I'm going to do is fill this down. I'm going to copy that function that I just wrote into the range of cells N3 through N7, and I'm going to copy by dragging on the fill handle. And because I'm going to be copying a function and I'm going to be copying that function down a column, the spreadsheet program is going to perform a relative copy and automatically adjust the row coordinates. So I have to get the mouse position just right, drag on the fill handle, and it tells me now that Mo has passed and Curly has passed, and you'll see that as expected then Shemp fails because he got a 57, and this guy fails. Joe Besser fails because he got a 69.2. He was 0.8 of a point off the mark there. So if that had been just a little bit higher, he would have passed. So there we have it. The spreadsheet program uses a logic function to assign one of two possible outcomes, either pass or fail. Now, make a mental note of what I just said, that the spreadsheet program uses an if function to assign one of two possible outcomes. It required one if function to determine one of two possible outcomes for each one of these cells. Okay, so why did I make a big deal out of that? Well, because the next thing I want to do is assign grades. And in assigning grades, there are going to be 5 possible outcomes. A, B, C, D, and F. Make 5 outcomes. So an if function has the capability, when used alone, has the capability of providing for 2 outcomes, but I need something that will provide for 5 outcomes. So what am I to do? Well, the answer is I am to nest if functions. Okay, so when we were working with this formula a moment ago, I used the term nest, which means that I use parentheses within parentheses, right? And so I'm going to do something similar here, except I'm going to nest if functions. I'm going to put an if function inside of an if function. And how many if functions will I need? The rule is you need one less if function than the total number of outcomes. So if I have 5 possible outcomes, that means that I'm going to need to have 4 if functions. And so in constructing that if function, I'm going to do it this way. I'm going to start out with the keyword if equal to start out with, and then if. And I'm going to check L2 first to see whether I should assign an A. So I'll check my Boolean expression will be L2 greater than equal 90. Okay, so there's the Boolean expression. If that's true, I want to assign the string literal A. If it's not true, I don't know what to assign yet. So what I'm going to do is have to make another decision. So if L2 doesn't store a value that translates into an A, I have to look further, decide further. I'll put in another if function. So the argument, my third argument in this if function is going to be another if function. And in constructing it, I will check L2 again, and I'll see if it has value greater than or equal to 80. If that's true, I'm going to provide the second argument with respect to this nested if function. So this is the second argument with respect to this nested if function. And if it is true that the cell stores a value greater than or equal to 80, I'm going to put in a B. I'm going to have it assigned string literal B. And if the cell does not store a value greater than or equal to 80, I don't know what to do yet. I have to make another decision. So I'm going to put in another if function that is going to be the third argument with respect to the if function that is nested within this if function. So it gets a little bit complicated. I think once it's done, you'll see how it works. And here I want to check to see if L2 is greater than equal to 70. And if it is, I want to assign the string literal C. And if it is not, I don't know what to assign. I still have to make another decision. I may have to assign a D, or I may have to assign an F. So in this case, I'll put in a third argument with respect to this if function, which is nested within this other if function, which is nested within the overall outer if function. And so this if function will read if, again, L2 greater than equals 60. And if that's the case, my second argument will be to assign the string literal D. And at that point, if the value stored in L2 does not translate into an A or a B or a C or a D, the only thing that it can translate into is an F. So my third argument relative to that interior nested if function is going to be a string value F. I don't have to make any decision to assign an F. And then I have to have this, a closing parenthesis for each of these opening parentheses. So I've taken care of 1, but I still have 1, 2, 3 left, I believe. And if I hit the enter key, I see that Mo with a score of 97 gets an A and he passes. That's good. That seems to make sense. If I drag on the fill handle, it's going to copy in a relative way. And I see that this next person gets a B, the next person gets an F as anticipated, the next person gets a B, and the next person gets a D as anticipated. So there you have it. There is the expression that's used to assign letter grades. And again, one way of making a decision that involves multiple outcomes is to nest an if function, and we'll find out there's yet another way to do this, completely different approach. But if I use nested if functions, what I need to do is consider the problem and determine the number of outcomes, and then the number of if functions that I'm going to need is going to be one less than the total number of outcomes. Okay, so hopefully that made sense, and I believe that's about everything I need to show you in this example, so I'll go ahead and stop, and thank you.